In this video, we are going to go over how to graph equations that are in slope-intercept form. If you haven't watched the previous video on explaining what slope-intercept form is all about, I suggest you check it out. But either way, this video will be helpful in showing you the process of how to do slope-intercept form graphing. Slope-intercept form is of the form y equals mx plus b, where m is the slope of your line and b is the y-intercept. Now, we are asked to graph y equals negative 1/5 x plus 4. In negative 1/5 x plus 4, the first thing we need to do, and I suggest this to all my students, is identify what your slope and y-intercept are. I start with the y-intercept because that's what I want students to start with when they graph it. The b value, your y-intercept, is going to occur at 4. So as a point on the graph, this will be at the point 0, 4. And the reason why it's at 0, 4 is, think about it. If I plug in the number 0 for x, you'd have negative 1/5 times 0 is 0 plus 4, meaning the x value of 0 corresponds with the y value of 4. Now that I've got my y-intercept, I'm going to plot that on my graph. So that's at 0, 4. 1, 2, 3, 4. And we call it the y-intercept again because we are going to cross the y-axis at y equals 4, or the point 0, 4. Then what I ask students to do is identify what the slope is. The slope again will tell us how steep the line will be. I like to think of it as what the line will be doing in terms of its movement all along its path. The slope is m, that is at negative 1/5. It's how we are going to be changing given the different x values we could be plugging in. So this tells me that we are going to rise negative 1, in other words, go down 1, and go right 5, right? So that's rise over run, or down 1, right 5. Let's do it. So now I'm going to go down 1, right. 1, 2, 3, 4, 5. Beautiful. And let's do one more point on the right side. Down 1, over 1, 2, 3, 4, 5. Beautiful. And now we'll go in the opposite direction, maybe one more point. So instead of going down 1, right 5, we'll go the opposite, which would be up 1, left 5. Up 1, over 1, 2, 3, 4, 5. And of course, we want to include all these points on the line and all the points in between. So I will graph, this is going to be tough. So I try to follow all my points, pretty close. And arrows at the end to symbolize that that line goes on forever. That's it, peeps. I'm going to show you 3 more examples in this video, so the video might go on a little bit, but I want you to get used to graphing different forms that slope-intercept form can come in. So different kinds of slopes, different kinds of y-intercepts, so that you are good no matter what comes your way. See you in the next problem in this video. And here we are in the second problem in this video, where we will go over how to graph slope-intercept form of y equals x minus 1. I thought to include this kind of problem because people will look at a problem like this where there's no number in front of the x and they think, oh my gosh, there's no slope. What do I do? Chill. There is most definitely a slope, and we will get to that. The slope is 1. If there's just an x here, that means that any number I plug in will be x itself. So if I plug in 4, it stays 4. If I plug in 5, it stays 5. What that means is I'm automatically multiplying that number by 1. So there's an invisible 1 right here, right? So you got that invisible 1. Now, well, let's write that as slope. That would be 1 over 1, so that you can think of it as rise over run. And that's it. So if you have an x sitting right there, write it as 1 over 1 to remind yourself that there is still movement going on here of, for every upward movement in the y direction of 1, we have an over movement of 1 in the x direction. I'm going to start, as I said earlier in the video, though, with my b value, which is negative 1. That is my y-intercept. Remember that that is the point 0, negative 1. That happens on the y-axis. Let's plot it. So 0, negative 1 happens right here. Boom! We've got a location to start with. Now what we need to do is figure out how to move from there. M for our, maybe it's for movement. Maybe not. So that would be 1 over 1. So that would be up 1, right 1. That's it. That's your rise over run. So we are going to start from the beginning, right? We begin at the y-intercept for b, and we move m 1, 1. That's kind of corny, but it might work for you. So we go up 1, right 1. Bam, put a point. Up 1, right 1. Put another point. Up 1, over 1. And you could keep going, up 1, over 1. Or we could go in the reverse direction here. We could go down 1, left 1, which is the reverse of up 1, right 1. And then maybe one more. down 1, left 1. Now we just draw a line connecting all the points. Bam! And there is yet another line with infinitely many points on it. We just happen to graph a few of those points. We have 2 more problems left in this video, so I'll come back to you in the next clip with a couple of other examples of slope-intercept form that differ just a little bit from what you've seen. And here we are in the third problem of graphing slope-intercept form. This says graph y equals 3 times x. Where's the y-intercept? There's no b value. What are we going to do? Oh, we're going to chill. We're going to calm down. And we're going to notice that there really is a b value here. If I have m times x with no b, that means b is technically 0. So for some students, it's helpful to put a plus 0 there. So your b value, your y-intercept, is going to occur at a b value of 0. And remember, that's an x value always of 0 because you're happening on the y-axis. That's neither left nor right, an x value of 0. And in this case, that's also a y value of 0. And you can see that if you plugged in 0, you get out 0. So 0, 0 is the y-intercept. Then, this time I'm going to do both the slope recognition and y-intercept, and then we'll do it all at once on the graph, just to change things up a little bit. The slope is 3, but it helps a lot of people to see it as rise over run, so you might want to rewrite that as 3 over 1. Pretty sweet. We're ready to go. We are going to begin at 0, 0, and then go up 3 and right 1 as our movement on our line. So we'll begin at 0, 0, that's this point right here, right at the origin. And then we will follow the directions the slope gives us. Rise 3, run 1. So we're going to rise up 1, 2, 3, run 1. Bam! Rise 3, 1, 2, 3, run 1. And then we can go in the opposite direction. Instead of going up 3 and right 1, we'll go down 3 and left 1. Down 1, 2, 3, left 1. And as we've done with other problems, when we have all these points, we plot them and then connect those dots. Beautiful. And try to be as accurate as you can with your line. That's it. That's all we've got. We end up with a nice line from our slope and y-intercept. In this case, when there is no y-intercept, there is one. It's not that there isn't one. It's at 0. We've got one more problem, and it's a sick one. I'll see you on the other side of this video for our 4th and final clip. Here we are in the 4th and final problem of graphing slope-intercept form. I've given you this problem. It says graph y equals 3 minus 4x. This is one where students often make the error and they look at it and say, oh, so my slope is 3 because, it comes first from left to right, and my y-intercept is -4. And I'm like, what are you talking about? The slope is -4 and the y-intercept is 3. The reason being is our number here is being multiplied by x. That's going to cause the change of going down 4 for every 1 additional x value we plug in when you were to plug in numbers for x. So to see this a little better, I often recommend to students to rewrite this with the variable and the coefficient, the number multiplied by the variable, going first. So that sign, that negative sign, remains with the 4 that belongs to the -4. So -4x plus 3. And when we rewrite the problem like this, it becomes very clear that the slope is -4 and the y-intercept is 3. Now we go about doing this as we've done the other problems in this video. So first things first, I begin with the y-intercept, which is 3. And remember, that's at the point 0, 3. Get in the habit of writing out that point so you know it as a location and not just as a memorized, value. The slope is -4. And as I've said before, that will often be a little confusing for some people when you're doing rise over run, so maybe put it over 1 so that you're looking at it as go down 4, right 1. Let's now graph it. I'm going to graph the point 0, 3, so that's up 1, 2, 3. And then from there, I am going to be going down 4 and then right 1, following the directions of my slope. So I will go down 4, 1, 2, 3, 4, right 1. And you know what? I'm just going to do 3 points this time. So I'll go in reverse here. Instead of going down 4, right 1, I'll go up 4, left 1. So that is up 1, 2, 3, 4, left 1. And we will connect those points and put an arrow at the end of our line. That's it. Slope-intercept form, it's all about where you're beginning, where you're starting, and that starting point is given to us by that b value, the y-intercept at 0, whatever that b value is. And then from there, it's about how do we move from that point. The slope tells us how we move up or down, and then always I graph to the right unless we're going backwards, to get points to the left. Awesome stuff. Go practice it. Get great at it. It will yield some great results for you.